chapter 3.3. All right, I'll try to stay pretty close to about right here so that you can hear this more effectively. If you listen to it on RenWeb, some of you guys have told me you've tried to listen to it and you can't really hear what I'm saying all that well. Chapter 3.3, angles formed by transversals. Okay? Now, what is a transversal? Can anybody tell me what is a transversal? I'm on page 121 in your textbook.
Right there.
Well, that's what it is. What would be a definition? Read it off the page. A line that intersects two or more coplanar lines at different points. Okay?
Right there.
Two or more coplanar lines at different points.
Jason, read it.
I'd like to remind you guys that not just my voice is being recorded, so is yours. That way, if I have a problem and a parent has a question about my judgment, I can get them to listen to class and they can make their own decision as to whatever it is I may have had to have done about whatever happened. All right?
Okay.
Now, transversal. If we have any two lines here, I'm going to just try to draw one very similar to what's in your book, okay? So this is line N, line N. We've got a line traversing those two, all right? We'll call this line, I think you're calling this line T. I kind of have a hard time saying it. Line T. We'll just call it line T, whatever it is. All right, so line T is a transversal. M and N are two coplanar lines. Lines contained within the same plane, right? So when we have a situation where there is a transversal cutting across two or more coplanar lines, different types or pairs of angles are generated as a result of this. Okay? So you've got a number of different types of angles, all right? You've got corresponding angles. I'm going to abbreviate a little bit here. Corresponding angles. You've got alternate interior angles. Alternate exterior angles. And same side interior angles. Okay, there's another set of angles that your book did not mention. Same side, exterior angles. Same side, exterior angle. So make sure you put that one in there. Not real sure why they left that one out, but okay. So let's do this. Let's say I number these angles angles 1 and 2, 3, and then 4. Okay. Let's look at 1, 2, 3, 4. Then we'll call this 5, 6, 7, 8. I'm not sure if that's exactly how your book numbered them. Yes, it is. Okay. Now, if we look at angles 1, 2, 3, 4, 5, 6, 7, 8, using these definitions, an example of what is meant by corresponding angles. They're angles that are in the same relative position with respect to each other in regards to that transversal. So I might look at angles 1 and angle 5. And I would call angle 1 and angle 5, if I'm going to put down an example of corresponding angles, I would say angle 1 and angle 5. You all see that? What would be another example of corresponding angles? 2 and what? 2 and 6. Right. So angles 2 and angles 6 would be another pair of corresponding angles. Alternate interior angles. All right? There's some definitions in your book, and you've already got a list of these definitions. Let's just look at what is meant by alternate interiors. You know, the interior, let me say this. The interior part, what is referred to as the interior part of a couple of lines cut by transversal, and the exterior part, this is referred to as the interior part. That area of space in between the two lines. Everything else is exterior. Okay? All of this space out here is exterior. So when I'm talking about alternate interior angles, your attention should be first of all drawn into the space in between the two lines. So alternate interiors are, what that is referring to is on different sides of the transversal. Alternate interior angles. Angles 3 and 6 would be angle 3 and angle 6 would be an example of what is meant by alternate interior angles. All right? Not 3 and 4. What would angles 3 and 4 be examples of? Adjacent angles. That would be another type of pair of angles that actually is created here. It's not mentioned here, but they are there. And let me go ahead and put them down, because you do have to worry about adjacent angles as well. They are in here. You have multiple sets of adjacent pairs. 1 and 2 is an adjacent pair. 1 and 3 is an adjacent pair. You get the picture? 3 and 4. But angles 3 and 6 are referred to as alternate interior angles. Mm-hmm. What's another pair of alternate interior angles?
4 and 5.
Not, yeah, right. Yeah, 4 and 5. That's right. 4 and 5. Okay. So alternate interiors, 4 and 5. I don't think that thinking got anything to do with this chord. We're going to do what we need up there. Okay. Let's move on. What would be an example of alternate exterior angles? Alternate exterior angles. What does that know? Hang on just one minute. All right, so examples of alternate exterior angles are going to be angles 1 and 8 and 2 and 7. You see that? 1 and 8, 2 and 7. All right, now note for these classifications, the lines do not need to be parallel. We'll talk about tomorrow unique situations that take place when transversals cut across parallel lines and relationships that the angles have to each other. Oh, you know, there's another set of angle pairs that are actually in here too that I forgot to make mention of. Can y'all think of what they might be? What's another kind of angle pair that is meant that we do have to deal with in diagrams like this? Vertical angles, remember those? What's an example of some vertical angles in here? Is 1 and 4 a vertical set? What else is a vertical set?
5 and 8.
Yeah. Or 6 and 7. Or 2 and 3, right? So yeah, don't forget about that. Vertical angles are also, so you've got multiple sets of angles that you're going to have to contend with here, and it'll help you in trying to figure out the relationships of the angles with respect to each other and trying to find angle measures as we go. Okay, so we've got corresponding angles, alternate interiors, alternate exteriors. What about same side interiors? Now, when we're talking about same side interiors, all right, same side interior angle, same side of the transversal in the area in between the two lines. So a set of angles 3 and 5 would be an example of that. 3. What would be another set of same side interior angles? Alex, what do you think? What would be another set of same side interior angles? 3 and 5 is one set.
1 6.
4 and 6. That's right. Angles 4 and angle 6. Okay? Now what about same side exterior angles?
6 and 2.
So, 6 and 2? No, 6 and 2 are corresponding.
So what would be like 8?
2 and 7 or 8 and, I'm sorry, same side and, I'm sorry, same side exterior, 2 and 8. Did you say 2 and 8? What did you?
Yeah, I said 8.
2 and 8. Whoever said what? It's 2 and 8, okay?
Well, yeah.
All right, what's another same side exterior pair? Yeah, anybody, really. 1 and 7, that's right. 1 and 7. All right? So what that does is it lets you know, those are examples. So you're going to need to refer to this a lot, okay? Let me look. Okay, your homework is going to be from pages 123 to 124, 1 through 32, all of them, okay? All of them, A-L-L.
122?
Yes. So page 123, 122, or yeah, 123 to 124. I want you to do 1 through 32, all of them, okay?